Intraoperative magnetic resonance imaging, such as MR thermometry, can improve the safety and efficacy of focus ultrasound surgeries. However, it is currently difficult to use magnetic resonance imaging to, in an intraoperative setting, visualize a volume of thermally ablated tissue. This is because thermally induced T2-weighted contrast takes some tens of minutes to first emerge after a tissue reaches an ablative temperature. The contrast then continues to evolve for many hours, rendering imprecise any volume estimates derived from T2-weighted intraoperative imaging. In this study, we hypothesized that diffusion-weighted imaging may provide an earlier indicator of thermal lesioning. Our study tests this hypothesis by lesioning 25 thalamic targets spread over 6 porcine craniotomy models. This study was conducted using a 3T-GE MR750 scanner, and lesions were generated using the Insightec Exablate Neuro device. Targets were insulated until they reached a target temperature of 60 degrees Celsius as measured using MR thermometry. After incination, targets were then monitored for 30 minutes using MRI scanning. During the monitoring session, diffusion-weighted and T2-weighted sequences were interleaved together to provide a time course of T2-weighted and diffusion-weighted contrast estimates. We also performed this monitoring session as a baseline measure before any incinations were made to any targets. Almost every treated target produced hyperintense contrast on intraoperative diffusion-weighted imaging. All lesions were visible on the same prescribed MR imaging plane. An example image with lesions identified with arrows are shown on the right-hand side of the screen. A small region of interest was placed over each lesion contrast and used to compute the average T2-weighted and diffusion-weighted contrast and apparent diffusion coefficient of each lesion. To facilitate comparison between these metrics, the T2-weighted and diffusion-weighted contrasts, as well as the apparent diffusion coefficient, were converted to z-scores by subtracting from each contrast at each time point the average contrast or apparent diffusion coefficient observed during the baseline imaging session, and then dividing this number by the through time standard deviation of the contrast as observed during the baseline monitoring session. To evaluate the conspicuity of contrast, 3 image reviewers, blind to all target locations and contrast type and sonication parameters, reviewed a random stream of all intraoperative images and identified the time point at which each lesion showed detectable diffusion-weighted and T2-weighted contrast. The earliest time points where at least 2 out of 3 reviewers agreed that a lesion was conspicuous was labeled consensus detection time. On to the results. When plotted as a function of time, the z-score showed on average an immediate increase in diffusion-weighted contrast relative to the baseline mean and standard deviation. This contrast increased with time after ablation. Meanwhile, the T2-weighted z-scores took approximately 20 minutes before displaying, on average, significant changes in contrast levels. We also observed, on average, a persistent decrease in the apparent diffusion coefficient z-scores at each target, and this decrease remained quite stable with time. We'd like to note that a decrease in z-score corresponds to a relative decrease in diffusivity, which is consistent with our hypothesis. We also noted that control regions, which were untreated by ultrasound and located in the cortex of the brain of the subjects, demonstrated an average increase in ADC z-scores, which may be due to scanner field shifts or may be physiologic in origin. Finally, on average, the image reviewers identified lesions using diffusion-weighted contrast at earlier time points than when using T2-weighted contrast. Using diffusion-weighted contrast, image reviewers found consensus detection times with an interquartile range of 3.7 to 11.8 minutes. However, when using T2 weighted contrast, the interquartile range shifted from 10.7 shifted to a range of 10.7 to 27.8 minutes. In conclusion, our study found that when intraoperatively monitoring focused ultrasound thermal ablations, lesions presented hyperintense diffusion-weighted contrast, that the apparent diffusion coefficient of the lesions decreased within a few minutes after reaching the target temperature, and that diffusion-weighted contrast could be found to emerge at earlier time points relative to T2-weighted contrast. Finally, I'd like to thank my collaborators and funding sources. Thank you for your attention, and I look forward to your questions and discussions as the conference continues. Thank you very much.